we can actually deal with angles larger than 90. What? How do you draw a triangle with an angle larger than 90 somewhere? Well, we sort of drop off triangles for a while. And when we talk about angles larger than 90, we talk about a general angle and something called standard position. And we can represent one on a coordinate plane, and this is why the quadrants are numbered the way they are. Because when we start talking about angles and standard position. So do you remember the numbering of the quadrants? We've got quadrant 1 is where x and y are both positive. Quadrant 1, quadrant 2, and they just go in a circle. Quadrant 3, quadrant 4. And the reason they're labeled in that order is because of what we're doing today. We're going to go back and use our angle theta, okay, our Greek letter. And let's say we have a really large angle theta. So if theta is between 0 and 90, it's going to be in the first quadrant. And what happens is it starts here on the positive x-axis. And let's say theta is really big. And it just goes around in a circle, like so. And that's our angle theta. That is an angle in standard position. It starts from the positive x-axis and it just goes counterclockwise or anti-clockwise until you reach your angle theta. And we say this is called the initial side and the terminal side, I think. Here, by the way, theta is 0 degrees. Okay, and if you're up here, theta is 90 degrees, right? If it goes to the positive y-axis. If it comes all the way around here, theta is going to be 180 degrees. And if it comes all the way around down to here, that would be theta is 270 degrees. And when you come all the way back here, theta is 360 degrees. So in a sense, 0 degrees and 360 degrees are the same angle when we're talking about standard position. Weird, right? So what are we talking about here? If my angle theta is down here somewhere, then this particular angle theta is between 180 and 270, isn't it? We don't know what it is. I just made it up. Okay, so that is an angle in standard position. And what we're going to do now is I'm going to give you a couple of values for theta, and I want you to sketch angles in this standard position. Let's give this a try. Draw the angle theta in standard position. So standard position is going to be on our coordinate plane. Theta is 135 degrees. So standard position, we're just going to do a coordinate plane. You don't need a ruler here. All right, this is just a sketch. Nothing's to scale here. We're not going to use a protractor or anything. Theta is 135. So which quadrant is that in is the first thing you've got to figure out. So we've got 0 to 90, 90 to 180. Theta is going to be there somewhere, isn't it? Okay, so here is theta. Okay, and that's pretty much it. That's all you need. B, negative 55 degrees. What? Negative? Hang on. Hold the phone. What's going on here? So x, y, and our 0. Negative 55 degrees. So if an angle is positive, we start from the positive x-axis and we go counterclockwise or anti-clockwise. But if we have a negative angle, then we're going to go back. So, okay, you can think of it this way. This is 0 degrees. What if we go backwards? Then you can think of this theta is negative 90. Okay, so remember before we said this is 270 degrees? We can also think of that as negative 90 degrees. In standard position, negative 90 degrees and positive 270 degrees are the same angle. Negative 55, so negative 45 is like right there, right? So this is just going to be a little bit further than that, a little closer to the negative y-axis. And you can draw theta like that. There you go. Theta is going to be negative 55 degrees. That's it. If you like, you can also do this. 135, negative 55 degrees. See, this is where it gets a little tricky. Let's switch over to radians. Yuck, not radians. 11 pi on 3. Ugh, what's that? Let's convert it. No, let's not convert it. Let's just think. This is going to be a multiple of pi over 3, so let's not worry about 11 pi over 3. Let's just think, what's pi over 3? Pi radians is 180 degrees. Well, what's pi over 3? If you divide both sides by 3, we get pi over 3 radians is 60 degrees. Okay, so this is 60 degrees times 11. Now, this is the best way to do this. Just watch what I do here. I'm going to divide this up so it's all divided into multiples of 60 degrees. So think of it this way. Where's 60 degrees? 60 degrees is going to be here. 60, 120, 180. Does that make sense? 60, 120, 180. So this is multiples of pi over 3. Pi over 3, 2 pi over 3, 3 pi over 3. 3 pi over 3 is just pi, which is 180. That makes sense, doesn't it? And then you can just extend these. Right, so we've got 60 degrees, 60 degrees, 60 degrees, 60 degrees, 60 degrees, 60 degrees. We have 6 lots of 60 degrees, which is 360, okay? Or another way you can think of it, 6 lots of 60 degrees is pi over 3. That's 2 pi. And 2 pi is 360, 1 full revolution, I think we talked about that. Okay, so each of these is pi over 3, and it's positive, and we have 11 of these. So think of it like this. Theta is 11 times pi over 3. So let's start. Starting here. Pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3, 7 pi over 3, 8 pi over 3, 9 pi over 3, 10 pi over 3, 11 pi over 3. There it is. Theta is 11 pi over 3. It is in the fourth quadrant. Okay, that is the best way to think of that. Okay, you can go and convert this, and you're going to get something. It's going to be in the hundreds of degrees, and you're going to go, what's that? Whatever that number is in the bottom, break up your coordinate plane into that angle and just count them. And we're also going to do it with this one as well. 7 pi over 4. So here we're going to think multiples of pi over 4. Pi over 4. So pi over 3 is 60. What's pi over 4? Divide both sides by 4. Pi over 4 is, so divide that by 2, we get 90. Divided by 2 again, 45 degrees. So pi over 4 is 45 degrees. So we're thinking multiples of 45 degrees. Let's think of this as theta equals negative 7 times pi over 4. Let's break this up into multiples of 45 degrees. So this is just going to be like that, like that. Each one of these quadrants is just going to get cut in half. 45, 90, 135, 180. Or in other words, pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. What's 4 pi over 4? 4 pi over 4 is pi, which is 180. That makes sense again. So let's do this. We're going negative this time, and we're going to do 7 lots of these 45-degree angles. So starting here, going negative. 1, 2, 3, 4, 5, 6, 7. There's angle theta. It's in the first quadrant. Theta equals negative 7 pi over 4. Okay, so there is the angle negative 7 pi over 4 in standard position.